Hello, welcome to my class. Today we are going to look at solid projection of a pentagonal prism, and we have been given a sample question here. The question reads, draw the projections of a pentagonal prism, base 25 mm side and axis 50 mm long, resting on one of its rectangular faces on the horizontal plane, with the axis inclined at 45 degrees to the vertical plane. So these are two conditions that we are going to fulfill as we shall be doing our solid projection. So the first condition, as the question reads, we are expecting to have our base, or what we are referring to as the base of a pentagonal prism, as a front on the vertical plane. It's like a rectangular prism. Our pentagonal prism is supposed to be held vertical. It's now going to be held such that it's lying on the base. It's lying on the rectangular face on the horizontal plane. And therefore, we expect the front to be rectangular in shape, the plan I mean, and then the front is going to be a pentagon. So this pentagon will be drawn on the vertical plane. So that means above, and then the rectangular face will be drawn on the base, that is on the HP. So let's do the necessary. So because the side length of our pentagon is 25 millimeters, we need to know how to draw this because it is a regular pentagon. Now we all know that to get the sum of the internal angles of a pentagon is normally given by n minus 2 multiplied by 180 gives us a total of 540. So to get the value of one angle is 540 divided by 5 sides, and this is 108. So we are going to draw a regular pentagon such that the angles in internal angles are going to be 108. So the first thing we are going to do is to draw our front elevation on the vertical plane or in the vertical plane, and therefore we can now measure our 25 millimeter as the side. So let's say we are starting from there, then from here we can now measure 25. Once we have 25, we can draw or measure angle 108 at the first point. So this one is our angle 108. You can measure here. So 108 is somewhere, because we are measuring this size of the angle, this is 1. So this is 90, 100. So this is 110, 80 here. Now we can draw that line. We can draw this line. At this other point again, we measure 108. Again, this is 100. This 110, 108 is here. Again, we draw this line. So we draw this. Actually, these are construction line. These are construction lines. Now we are going to take our 25 millimeter. We transfer here. Then we use an arc to connect the two. So we proceed in such a way that we pick this distance with your compass. You stand at it at one end and then you make an arc. Bring this, make another arc, come here, cross, and then again come here and finish. So this one gives us our pentagon. We can join the points. So having this in mind, we realize that because it is lying on the horizon, the prism is lying on one of the rectangular faces, then it means on the vertical plane, because vertically is the vertical plane. Let me just show an illustration. So these are two planes. This one is the horizontal plane and this one is the vertical plane. So it's like we are taking the pentagonal prism lies such that the pentagonal part is going to be formed on the vertical side, and that's why we are having it here. So the pentagonal, that is how we expect to have. And now on this horizontal plane, we expect it to be lying such that we are going to have the plan in that manner. Okay, this is projection. You project, you project, so that now, because this is x, y, gives us something close to that. So what we have drawn is this, and now we want to draw this. How do we draw it? We can have a distance, can start somewhere below. Let's say start from here and now we shall project the distance of the corners of our pentagon to the baseline. So we project this, project this. So we just project so that now we get to measure our axis, so that now our plan is rectangular. This is just projection of those lines. So what is the distance of our, according to our question, the axis is 50 millimeter. So we measure 50 millimeter from here, get it's here, so we join. So now it becomes this way, but remember, observing from top, this line and this line will appear hidden, so it's not going to be continuous line. The final drawing, this one will be hidden. These ones are hidden lines. This one is a hidden line. In our final plan, we don't expect, so we shall have hidden, and this one will be complete. You can complete it, actually doing it once and for all. This one here can also be completed, and this one is completed. So we are through with the first condition. This is the first condition. We just expected to draw a plan and our front in that manner. Now we are going to number these corners so that this one is A. We can use letters. We can start by having this 1.1 A, 0.2 B, 0.3 C, 0.4 D, 0.5 E. Once we have that, we can now project downwards. This is 3. Okay, on top we can have letters. This is C, this is D, this is B, and this is A. This other side now we have numbers. This is 1, this is 5, this is 4, and this one is 3. Now we are going to tilt this axis. The axis, of course, the axis is this line that is passing through from the vertex downwards. We can have it this way, so that we draw it from top. Actually, that line, it is here. It's going, actually this one was A, this one was A, and this is B, and now this one becomes 2. That's just a small correction. Now once we have done this, we are going to tilt this axis at 45 degree. So we are going to measure 45 degree line, and then we come up with this 45 against the VP, so we can have it. So let's say we are having that point as our point of reference. We can start from there, so that we put this here, then we get to see where 45 is, because this one is the tilting is 45. Here it is. So we can draw it from that point as a reference. Now once we have that, we are going to draw 90. That means we have another angle at this line from here to here. It's perpendicular to this, so we draw a line perpendicular to this other side. We can use this. So this line, it goes. Then we now transfer whatever we have here, there, using your compass. Just transfer A, C, you bring it here, okay. Then next is A, D, A, E, this is E, we can as well draw this other line. Let's do this way, because we want this. We want this line parallel from the end point, so we can bring here, somewhere here, then we draw it. So we complete our rectangular base, so that now it is tilted. Okay, now again we carry the axis height, just come with it, then bring it here, you cut that. Okay, once you've cut, you can still complete. Now you are going to draw these other lines. You can still carry the way they are, or just use your set square to draw them. So the first one is, let's say we are doing this, so we start here, like we are drawing parallel lines. Come here, There it is. So bring this. Bring this. Bring that. Okay, so we are done with that. We can name. So this is A. So we just transfer whatever the points that are here. We transfer them here. And these ones again, we transfer them there. So the next thing, we are going to project lines from our front to move on the right from the top. So we move this, we project this line, project it. We shall also project this other one. Okay, now we project this. This one already been projected. So again, we project the ones from the plan vertical upwards. So project from here. So this one is projected. Sorry for that. And then again this one. Project this. Project this. Project that. Same applies to this other side. Project them. So the projections are that A come and then you meet another A here, so you put a point. Then E comes, meets E here, put a point. Okay, this is E. B comes, meets B here. D comes, meets D here. Then lastly C comes, meets C here. Vertical is C on this side. Okay, now once we have that, we are going to draw, because this we get to see which one is visible, which one is not visible. In this case, this line is visible, then this one is visible. Of course, this one again will be visible from top if you view this, but this one will not be visible, so it is hidden. So we shall have the hidden line. Then again on this other side, be hidden. Okay, lastly we do again this other side, so we just do the same thing. This is 1, it meets 1, so this is 1, 1. 4, here is 4. Then last 3, here is 3. So again, this one here, the whole of it will be visible. All the lines here will be visible. It goes that way. Goes this way. Actually, this one was supposed to be hidden line. Then this one, proceed, come, draw this way, and complete this. We shall have to join this other part. And again, shall have a full of this. then this one, okay, and this one will be hidden line, this one here will be hidden, and now this one here is full line, is full, this is full, is a full line, and this one is also a full line. That's how we are supposed to complete, so that we can have our drawing. Sorry for that. We can have our drawing the way it is. So far these are the views that we expected to have in solid projection of our pentagonal prism for that has fulfilled two conditions. We say this one is 45 degrees. 5 degrees. If we tilt, then we can get our plan, our front to appear this way, viewing it from this side. Because this one here have to complete exactly, so that now this one here goes and this one goes. This is viewed. It looks now more clearer. That's what we expected to have. This line is hidden, this one is hidden. If you view this one from the front, from the plan of this, is what you get, and then this one here gives us that. So in short, that's what you are supposed to do. Thanks for watching. I consider subscribing to the channel.